Hello everyone, and welcome to your remotely delivered course on solid mechanics. In this short video, I will give you a brief introduction on what solid or continuum mechanics is. When applied to particles, Newton's equations of motion predict that a particle accelerates according to its mass and the forces applied to it. A particle accelerates in the direction of the resultant force applied onto it. Solid or continuum mechanics extend Newton's laws from particles to a continuum. In order to extend the subject to a continuum, the first step is to understand how to mathematically describe a continuum. Afterwards, we will discuss how to describe the deformation of a continuum, which involves finding the relative position of points with respect to one another, resulting in local strains. In particular, the points inside a continuum are no longer treated as isolated particles, but they interact with their neighboring points by exerting stresses on them. In order to find the stresses, Newton's equation of equilibrium are extended to differential equations of equilibrium whose solution provide the local stresses and strains within a continuum. At the end of the course, we will present beams as a perfect application of the continuum mechanics theories and tools described in this course. In the following video, I present an example application of the topics studied in this course. The video shows a metal rod that is used to strike a metal bone implant in the interest of examining the interface between the implant and the surrounding bone material. The simulation provides the relative deformation between the different components. The colors that you see or contour plot provide the stress distribution during the striking process. In this course, we will study the mathematical tools behind simulations like this. I hope you enjoy your journey through continuum mechanics this term. Please drop me a line if you have any questions.